So this is a sneak preview into Laplace's transform. A Laplace transform serves as a useful tool in solving an ordinary differential equation without actually finding the general solution. So if f is a real-valued function defined for all t greater than or equal to 0, then the Laplace transform of ft is denoted by LFT, and it is defined as integral t equal to 0 to infinity e raised to minus st ft dt. So coming to problems, find LFT when ft is t when t lies between 0 and 4 equal to 5 when t is greater than 4. So as per the definition, LFT will be integral 0 to infinity e raised to minus st ft dt. So we split this as integral 0 to 4 e raised to minus st dt plus integral 4 to infinity e raised to minus st ft dt, because it's divided between t equal to 4 and greater than 4. So that will be, now between t equal to 0 to 4, ft is t. So it will be integral 0 to 4 t e raised to minus st dt, and greater than 4 it will be 5. So this will be 5 e raised to minus st dt. So use integration by parts here, you get u integral v. So t integral e raised to minus st divided by derivative of minus st is minus s within the limit 0 to 4 minus integral 0 to 4 derivative of t is 1 minus will give you plus e raised to minus st by s dt. Plus you can take out the 5. This is again e raised to minus st by minus s within the limits 4 to infinity. So that will give you, take out the minus sign, minus 4 by s e raised to minus 4s minus 0. Again when you integrate you get e raised to minus st by minus s squared within the limit 0 to 4. You can take out the minus sign here, so you get minus 5 by s e raised to minus st within the limits 4 to infinity. That will give you minus 4 by s e raised to minus 4s. This is minus 1 by s squared e raised to minus 4s minus e raised to 0 is 1. A common mistake which students make is they'll put this as 0. But remember that e raised to 0 is 1. Minus 5 by s, 1 by infinity is 0. So 0 minus e raised to minus 4s. That will be minus 4 by s e raised to minus 4s. Minus, open the bracket, minus 1 by s squared e raised to minus 4s plus 1 by s squared minus plus 5 by s e raised to minus 4s. So that will be 1 by s e raised to minus 4s, because you get minus 4 by s e raised to minus 4s plus 5 by s e raised to minus 4s. That is 1 by s e raised to minus 4s plus 1 by s squared 1 minus e raised to minus 4s. Coming to the next question, find LFT if ft is sine 2t where t lies between 0 and pi equal to 0 when t is greater than pi. Again LFT is integral 0 to infinity e raised to minus st ft dt, that is integral 0 to pi e raised to minus st ft dt plus integral pi to infinity e raised to minus st ft dt. Between 0 to pi it is sine 2t. So it will be e raised to minus st sine 2t dt, and here it is 0. Now we use a formula in integrals, namely integral e raised to a t sine bt dt is e raised to at by a squared plus b squared a sine bt minus b cos bt. So using this becomes e raised to minus st by s squared plus 4, and you get minus s sine 2t plus 2 minus 2 cos 2t within the limit 0 to pi. That will be e raised to minus st by s squared s pi by s squared plus 4. Sin pi is 0, 0 minus cos 2 pi is 1. Minus 1 by s squared plus 4 e raised to 0 is 1. Note this step, into 0 minus cos 0 is 1. So when you simplify you get 1 by s squared plus 4. This will be 2 minus 2 e raised to minus pi s, that is 2 by s squared plus 4 into 1 minus e raised to minus pi s. Coming to the next question, find LFT if ft is e raised to t when t lies between 0 and 1 equal to 0 when t greater than 1. Again we use the definition LFT is integral 0 to infinity e raised to minus st ft dt. That will be integral 0 to 1 e raised to minus st. Between 0 to 1 it is e raised to t dt, and the rest of the term is 0. So that will be integral 0 to 1 e raised to t minus st dt. We are using law of indices. E raised to m into a raised to n is a raised to m plus n. So integrating you get e raised to, that is integral 0 to 1 e raised to t into 1 minus s dt. So integrating you get e raised to t into 1 minus s by 1 minus s within the limit 0 to 1. That is 1 by 1 minus s. This becomes e raised to 1 minus s minus e raised to 0 is 1. So that concludes the small sneak preview into Laplace transforms. Do let me know if you need any further help. Thank you.